Hello. And again, welcome. Today we get to greet Maisaka. No, wait. Alvatore DeMarco. Control underscore O. Ashunt Sun. Emilize. Imagine Maisaka chatting in the chat. Couldn't be. Wait a minute. It could be me. It could be me. How peculiar. Ding. Ding. Fries are done. Enough ding. Hmm. Very Very I don't know if I should get myself a snack or something, but I don't know what to make. Oh, very perplexing. Very highly perplexing. I'm so behind on like starting stuff up. Oh, so slightly E. Now let's see if I can't stack these any better. Oh, maybe I can. Maybe. Yeah. Yeah. I don't know if there's enough. It is the Kirim. Again. Hello, hello. Somewhat hello. Somewhat hello. I'm debating on whether or not I get like some sort of some sort of like snack or something to eat. Cause I'm realizing that like it's probably been a few hours. Would have been back, but there's I don't know stream stuff to set up. I like have to set things up. So do my setup and then I can like go and take breaks. That's sort of the procedure, kind of, sort of. I mean, I did get myself water, at the very least, but I didn't find anything that would make for good, like, snack time. I don't have cookies. Even if I had cookies, I don't know if I'd want to, like, relegate myself to eating nothing but cookies. Would I share the cookies? I would probably share the cookies. This is sort of an important aspect of cookie. Discreetly steal the rest of the cookies? Why would you have to just steal my cookies? Why would you steal the cookies? What did the cookies ever do to you? Ugh, I should probably see about locating some kind of snack. Maybe? Probably. You're trying to bad apple the Maisaka? Right when I get up? Yeah? Yeah. Yeah. I don't know why it wouldn't work. It's part of standard operating procedure. Make sure everything is functional. But yeah, I really do need to make myself something. So, is that. There is some of that. Very early snack time. Like what even? The problem is, I don't know what to make. I never know what to make. And it has to be something sort of simple-ish. So it can be prepared in somewhat short order. Cinnamon toast. I don't know if we have bread or not. I would have to find out. It's too often the case is that we either have a ton of bread that no one eats, or like no bread. No one's eating it. Great, now I'm gonna have to find myself bread or something. Bread or something. Anyways, I'm gonna hunt down something to munch on because I'm not gonna last very long otherwise. have begun the process of toasting stuff. And for the moment, I have returned. It is a brief moment, I suppose. Probably. Perhaps. Phase shift. Chibi shift. Gotta be careful with that chibi shift. You never know when I'm be like tempted to like leave myself chibi for like half the stream. Cause that's not something that I, oh wait. That is it. That is something that I do. I'm just like, yep. Everybody be chibi. So much E. So very much, I just want my snack to be done. I am so incredibly impatient. Always. Also, check out this crazy CPU graph. Wild. Wild and crazy. Maybe not like super crazy or anything, but it's a little up there. It's definitely blinky. ASCII? No, not at all. This is the BTOP application. BTOP utilizes a series of like Unicode characters. So like a bunch of symbols from the Unicode character set to display things as like, I don't know, symbols and so on and so forth. In particular, you got these things. These silly little things are what are called the Braille character set. So, you may have heard of Braille. It is like a series of like dots, usually printed on like raised paper or plastic. And you can run your fingers over these things. And each one corresponds to like letters. It's typically used for a reading assistive device for like blind people. However, the Unicode standard has like character symbols for them. And thus, there's like a Unicode representation for all of the different states of the Braille characters. There's, what is it, eight different dots per symbol, per glyph. And Unicode has like one glyph where all the dots are in all the different states. Which means that there's like probably 255 different Braille characters somewhere in the Unicode ranges. And you can just display these things in decently compatible terminals. I should probably point out, however, that there's some subset of these that are like not even allowed in my like chat. Like AutoMod will probably catch you for using these. Because they get abused a lot. Been at least 6 minutes. I should probably check to see if my food has been toasted thoroughly. I think it was one very specific one, like the full 8-dot one. Maybe. I certainly didn't grab all of them. Hello and welcome to the F Mega. I'm going to be right back. I put some food in the toaster, and I have to go grab that. Very, so much, so much, return. Yeah. Let's see, what is this? This is very early snack time, The color equals blue. Or does it? You know, maybe you don't know. There's actually something that I discovered that you could do with my chat box. And I wasn't really aware that you could make it do this until like somebody tried it, and I'm like, that's interesting. So one of the rare features that I added is that you can type like hexadecimal color codes. But I found out, somewhat incidentally, that if you type something that's like not a letter, it glues the color code. I thought about unconnecting it, like making it not do that. But I'm like, it's actually kind of fun. I'm just gonna leave it. So, yeah. I'm almost willing just to make it a feature. Make it so you can stick spaces or something in it. Mm. Next time we poke at the chat box, probably. Crunchy. Got 30% of my CPU just getting toasted constantly. Kind of like my snack. I don't know if I like that. Toasty snack is good. Toasty CPU, less so. Something I was thinking of today, earlier, is that, like, my past couple of streams, they've been about this operating system thing that I've been writing. I decided that I would, like, start on the deep end, write myself a shell, interpreter thing. I think I've stumbled into something a little bit deeper than just a shell. It's also ad break time again. Oof. Which is the push toy. Hello, hello. I've set up a VM today. And you regret using the Windows 11. It wants to take all of your data. And crunch it. And 12 hours is too long. I prefer if my streams will stay like around or less than 8. Preferably without the hugest of cliffhangers. But then, yeah, maybe I should just leave the streams. Maybe I should just end streams on cliffhangers. Maybe that's the secret, getting people to come back later. It's just to be like, oh, it doesn't work, but we're gonna finish it, and then the next stream. Ow. All right, what do we got for streams here? 11 hours, 16 minutes. 9 hours, 51 minutes. 9 hours, 11 hours, 52 minutes. 11 hours, 55 minutes. 11 hours, 52 minutes. 13 hours, 14 minutes. 9 hours, 54 minutes. 15 hours, 22 minutes. 9 hours, 56 minutes. 11 hours, 57 minutes. 11 hours, 30 minutes. 10 hours, 50 minutes. 10 hours, 30 minutes. 9 hours, 7 minutes. 10 hours, 43 minutes. 10 hours, 49 minutes. 8 hours, 30 minutes. 12 hours, 9 minutes. 8 hours, and 19 minutes. I clearly go a little bit longer than I normally would want. And I seem to be making a habit of it. So yeah, I could say that I want to keep my streams from like hitting 12 hours, but that doesn't mean that I'm always going to be successful. Also, hello and welcome to Graffiti 82, Crazy Kitty, and Stegosaurus 21. Would it be silly of me to shout out the Crazy Kitty? Probably not. Probably not. More clink, more clunk. More ping pong. Maybe, probably, perhaps. Well, it's now that I've like ate my snack, my toasty bread. I have to be right back again. Oh, yeah. Bread. Bread. More bread. Kind of realized that my diet here today consists of oatmeal, bread, and water. Clearly, I'm being sent to the gulag. The gulag. So for the curious, I was coaxed into like running the duck program in the background for various times where I take breaks throughout the stream. It uses 33%, a third of my CPU. It uses 1/3 of a 24-core CPU to run this program. There's something just slightly off about that. And I don't know what it is. Anyways, now that I'm not getting, like, interrupted by being ridiculously hungry or random ad break time, maybe I can collect my thought from earlier. My project for the last couple of streams has been to build a lexer and a parser for the shell command language. Because I've essentially been trying to make an operating system. And so I figured, oh, I would start with, like, basic operating system stuff that everyone uses. The sh command, sh utilities, all the little Linux and Unix utilities like ls and cp and change all the things and false and find and rm and rmdir and move and echo and so on and so forth. And a thought occurred to me. Something somewhat profound occurred to me. Which is, like, maybe not all that profound if you really think about it. But also it's a little profound almost in a way. We're building a parser. Something to turn text into syntax trees. Of course, we're doing this for the shell language. But if I were to look through this list of things that we need to do, we also need to take care of stuff like sed, which is a language. We need to take care of awk, which is a language. We need to take care of M4, which is technically a language. I will probably have to take care of, like, make files, which is also sort of a language. And I was thinking to myself, what if the parser is not exclusively for shell? There's a lot of things in here besides things that are languages, but, like, I have this subset of utilities, and of them, there's like 3 or 4 that are, like, language related. Like test. Test is a shell script utility. You could essentially assume that test is in some really messed up way a language, a very simple one. Even though that's not entirely accurate. Sed arguably could be considered a language, kind of, a very simple one, but it uses regular expressions, so maybe less, less, less. Less something. It's less of a language and more like something that heavily leverages regular expressions. But it could be almost. Almost. Awk is a language. Although I feel like there's some subset of it that I could get away with implementing. M4 is kind of a language. But some of the stuff from the absolutely cursed category here, which might not actually be absolutely cursed. A C compiler in JavaScript, for example. We don't necessarily need to go all the way down to C. But if I had something that's like capable of parsing C, why does this exist even? So the operating system here, called ECMA OS, and the idea was to use like JavaScript and like various ECMAScript features to make an operating system. The core of an operating system. And one of the things that we can't really escape from is the fact that ECMAScript is not really a systems language per se, so you can't really make like programs with it. Like you sort of can, but also not quite. So one of my thoughts here was to take C programs, which exist in abundance, and try to like turn them into JavaScript. This is a terrible idea. I kind of concluded that it was a terrible idea. But I did sort of have a side thought to it, which was, if we're going to depend on like GCC is a C compiler, and yes, I could just have this sitting around and it could do the thing that it needs to do, and it could exist, and it could probably function, and this would sort of maybe be acceptable. But what if I entertain the notion that we don't need GCC? What if JavaScript could do everything? What if JavaScript could just compile the C library? What if JavaScript itself could build Node? What if we didn't need all of the fluff that GCC brings, or that Node brings? What if we don't need the C library at all? Of course, that would be sort of like very, very, very far down the tree. Because if I replace the C library with something written in JavaScript, that means rewriting the entirety of the C library, which is kind of sort of like a hassle. The C library has a lot of functions in it. A lot of functions in it. And even if you, like, ignore some of the more egregious ones, there's still a lot of functions. So, one thought was if I could do this gradually, and that we could, like, maybe experiment with, like, different parts of these kinds of components to see, like, how hard would it actually be? Which is why I label this section absolutely cursed. Because even if I got around to it, I'm not sure if I would actually want to deep dive into replacing libc or like building C compilers, but I like making compilers. I think it's kind of fun. I think it's kind of entertaining, which is why I left this stuff in my list at all. Because I like the whole process of like taking words, text, symbols, and turning them into like these structured syntax trees, and then like generating commands and stuff from them. I find this whole entire process very, very intriguing. To the point where like I've written assemblers, I've written some like custom language compilers a few different times. I've written parsers for a bunch of things. So my thought earlier today was that if there's so much stuff that exists in the world of systems that involves like taking text, applying some lexicographic rules to it, and then like applying some grammatical rules to it to turn it into a syntax tree. What if I built into my operating system some piece of code that is dedicated to running lexicographic processing and grammatical processing for just like any arbitrary language that I might be able to find? Because if you think about it, awk, shell, send, M4, make files, all of these things have configuration files or like input files or input text that needs parsing. What if the parser was common to all of these components? And then what if that parser could be extended to other components? Like at some point, I entertained the idea of writing or finding a Python interpreter in JavaScript. Which is sort of eek. But possibly required for like node compatibility, I believe. You have to use the Python to make a lexer and a parser. Like, this is not an uncommon thing. It's really not. So this is hardly surprising. Because, like, if I were to continue my thought about what might require lexers and parsers in the future, like, what if, let's say, I wanted to make my system more, I don't know, more Unix-like, maybe. What if I wanted to introduce more of the user space of a typical, like, Unix system? A lot of these things have configuration files. Some of the configuration files have their own, like, syntax. Syntax that I would have to parse again in some way or another. So if it was just built into the operating system to let me, like, parse all the things, then like, I might be set. I might just be good if we parse all the things. I feel like I'm gonna sneeze. Somewhat ache. In my previous stream, I pulled all of the shell grammar rules out of the specification, and we formatted them as, like, these giant arrays of like tokenized elements. And I have been thinking to myself a little bit about how I might want to take all of the grammar rules here and make a function that will parse the grammar in sort of like a generic fashion. Which is not an uncommon thing. There's actually a project that exists that already does some of this. It's called Tree Sitter. And, like, it supports a whole bunch of different languages, and it's essentially just a parsing library or something like this. So I almost wonder if, like, I could leverage something like Tree Sitter or write something similar to it to basically accomplish the same sort of, like, task. But now that we're thinking about it, now that is sort of on my mind, Maybe tree sitter itself is the answer to the problem that I was pondering. Of course, I can't really be sure. The language. This is grammar rules. So these are basically, it's just like JavaScript, but it's formatted obnoxiously. Because it's a series of grammar rules. So like this is just an array of arrays of objects. And then I have a whole bunch of these. And they form sort of like a tree-like structure of things that we're going to be able to, like, maybe parse. And I put this together at the end of my last stream. I kind of thought about how I might use it a little bit. But today, we're actually going to, like, try to apply this in some way. We're gonna try to make a parser that can take an array of tokens and my grammar, and it should spit out a syntax tree. And like, if I do this, I think I will be a little bit closer to kind of like my goal of having a generic parser thing. A lot of the formatting for this is just kind of lifted pretty much straight up as is from the POSIX standard. Just kind of wrapped it a little bit in the syntax to make it work. Also, hello and welcome to This I Will and Kage Jitai. Occasionally I greet people. Occasionally I forget. Occasionally. So right now, the way my shell works, or my shell parser works, it just has a custom written thing, which is like, oh, this token appeared, do this thing. But we don't want to just do it with like any other token. The language workers, the parsers, Parkers, Peter Parker, Spider-Man. I don't know how my brain just went and connected a bunch of words together in a really weird. But the language parsers are Spider-Man. E. So much E. They don't want to, like, most language parsers don't really want to cooperate. They probably don't cooperate. But if I can make a generic parser, some sort of generic rule parser, generic grammar parser, like, this is not something that's terribly uncommon. The tools, Lex, and what is that other one? Yak? These are like Linux, Unix? Little Unix utilities for generating C programs with like different rules. And those were kind of like an early solution to the same sort of problem, where like tons of things want to like parse text. So there are semi-standard utilities for doing it. Somewhat, almost, probably, but not quite. I keep scrolling around in here. Scrolling around in here, and I'm just like, maybe. Instead of staring at it, instead of staring at all the data, maybe I try to build out some sort of framework to walk through the grammar list. My original parser here is called shell expand. And I don't know that we want to push the new line in it. No, we want new line. Pretty sure. Pretty sure. Not sure. Not sure. I am sure of one thing, though. We want to start off with program. So it would be console. We want to log program, which is a grammar item array. I think we just return for the time being. Like, just make the whole thing a bunch of dead code. And this will give me, like, an array. And the array is going to have a series of alternate options. Each option here is basically, like, a path that we could take into the grammar to make things happen. It's kind of like what we might expect. What is expected here? What can we expect? If we go through and let's say we pick an alternate of the program array. And we should be able to log alternate, which is just like just the array of arrays. The array of objects. We have array of object. Too many objects. So we want to descend into the alternate array. Have like expected. Like what are the expected tokens or whatever. We got some circular references. Yummy. That's kind of expected. That's kind of sort of expected. There's another problem with these, and that's none of them have names. None of my grammar items have names. Let's see here. I think I should take what's it called? I'm gonna take a series of word. We're gonna take the equals. These should all just be grammar item. Right? Right. I'm gonna have our word. Say they are grammar item. And they're gonna be empty objects. More. Bad apple saka. Gulber. Very E. Also, hello and welcome to the Sky Gray TV. I should probably, I think we will. We will shout out the Sky Gray TV. Very fun channel. Can highly recommend. I always enjoy my time there. Where do I want to put this? It can go here. And now I can give this thing a name. The line break. Cooler Fox channel. Or maybe I'm just the crazy Fox channel. Or maybe I'm not, I don't know. I should have put the name item in all of these. And I didn't. A very eek. Can we just like end of line, back up? Nope, I did it wrong. End of line, back up. Not that. Go here, insert name. escape, go down. Okay. Just do this. I really should have made this something that we do with regular expression, though. Like, really, really. I'm gonna put you here? Okay. Or no, we want to put this here. Or maybe we put it in another group. Or we just have, like, I don't know, anything? Just sort of anything and everything? And then we do item 1, item 2, item 1 again, and an ending delimiter. And now it has all the names. Oh, lovely. About as lovely as it can be. It's kind of hideous looking. A part of me would love if, like, all the items were not just bleh all over the place. That's probably a bit much to ask of the fox right now, though. Anyways, if we do this, it will, like, put names into the alternates so I know what they are. So basically, like, I want to find a representation for program, for example, such that it will generate a series of, I guess you would call them, like, terminal tokens or whatever. Something where whatever input is determines, like, what kind of grammar we end up emitting. But in order to do that, there's a problem. There appears to be a problem. There's no problem here. It's built that way by design. The bad apple Maisaka just changes my hair to, like, a video. So if I happen to have a video playing in the background, which some of my media playlist is music, some of it's video. If it happens to be playing a video, it will capture the video and put that there instead. Actually kind of interesting the way it works. So it's like a bonus feature. Also, hello and welcome to the Ricardo Strikey. The Ekmos. I keep wanting to call it like Ekchaos. Ekchaos. Because it's very E and it's very chaotic. She's full of chaos. A very extremely chaos. I don't know if we will, though. The hollow projector. We are hollow and projected. Chaos. And then it sort of loses a bit of its identity a little bit. Is my other problem. Plus, there's probably already something out there. Which is called chaos. Also, hello and welcome to the Nympheus. Let's see here. If we have expected item here, for example, let's see if I can, for instance, figure out line break. Line break is one of those things that contains what is called the empty token. And I think that's probably arguably going to be the more obnoxious item that we run into here. It could either be something that is empty or something that is not empty. Probably. Maybe. Possibly. Perhaps. So I guess to determine if a valid alternate is something that exists. I suppose I would want I think I want some sort of way of doing recursion. Should be like, I don't know, descend, grammar. I want to step into program. So we will have our grammar, which are grammar item array. Or no, what is that thing? It's grammar item. We want the grammar item itself. program is not one of the grammar items. Program is sort of like implicit. Maybe this should be one of these. You should be grammar item. We'll have a and we'll have name. So now you can be program and you can have name. So we can have some sort of log of the item. It's raining. It's raining. What are you? You are a step. And then we want to get rid of that. Maybe I do want to hard cast them. I don't know. I don't know. I guess we'll leave it like that. So we have a step, we have an alternate. An alternate is going to have different items that it could possibly match. So we should have like probably our first alternates. What are you? You are string or lex token or grammar item. So let's see, if you are an object, and what else would it be? I guess if the expected item has, it's called name, should be a grammar item. Which means that we can add the name. Which will also become sort of useful in a moment. No, what do we want here? We want to check if the alt has a length. We want to put a little separator in it. A little tiny separator, and then I want to like display this at the end. So then I can get sort of a more I don't know, representative pattern. Alright, so the next thing I want to check here is if the expected item is one of these grammar rule things, grammar items. I want to recursively call into this descend function. But probably only on item 0. I'm gonna say probably on item 0. So we might do this with a numeric loop. Have some sort of flavor of index. If the index I is 0. We want to descend into the expected grammar item. So now what this should do is call into the stack and exceed the stack call size. Yeah, overflow the stack. That sounds like a great idea. Because apparently the item is already in my list somehow. Except that it's kind of, in some way, some sort of fashion, not really properly being handled here. So I'm going to need to keep track of what possible rules we have applied to the grammar. And there's probably also some other way of building out the alternates so that it makes sense. Because things in the grammar can technically repeat, and they will technically repeat until something hath been done about it. So one way of like catching this would be just maybe like visited. You can be a set of grammar item. Not the chicken. The crunchy, chewy chicken. So we say visited. Has the grammar. Then we will add this object so it only gets hit once. So we really don't want to overload the stack. That would be kind of E. All right, so you terminate now, right? I think so. We have program, line break, new line list. So I want to print out the so-called alternates. And then, what are you? You're going to be a grammar item or undefined. Because I want to print this out if we have an item. In such a way that it shows me what all the alternates are before stepping into them. Like so. We have program, we have line break, so we'll step into line break. Line break consists of a new line list, a new line list. We step into that, we can have end of the line, a new line list, or an end of the line, or we can have an empty, or we can have another line break. Or is that from the previous step? I don't know. It's hard to tell. And now my terminal is smiling at me awkwardly. So yeah, new line list consists of end of line, new line list, end of line. So it's recursive. Recursive, go burr. Recursive item, go burr. And then line break are just kind of like empty. Line break has the empty token in it, which means that almost everything could be a line break. Everyone can have a line break. You get a line break. You get a line break. You get a line break. But we probably don't want to put line breaks everywhere. Especially because we might assume that we might assume that empty token is not going to match some token. Like, we definitely want to find token. We want to be able to find token. And I also want the grammar parser to be able to support recursion, because there is lots and lots of recursion in this system. Take the new line list, for example. This is sort of like object which I don't know if we really care too much about it. Like, it's basically what? A bunch of end of lines, basically. And then line break. Yeah, you can either be end of line or like a new line list. Very yeah. So much yeah. It's not really a token though. It is not really a token though. Like, if we're trying to find possible tokens, what the tokens might match up against, then then a wild sin bleed appears. Hello. And again, welcome. patch. Your pushing patch for the kernel LSM and keyring verification for the PKCS7. Everyone needs some good old-fashioned PKCS7. Oh my god, what kind of E? Basically just like one of the standard formats for certificates and key data. Notepad runs. I'm not sure what you mean by this statement. The notepad. Notepad runs over. Like, I know some of these words and acronyms. But like, is this sort of like I don't know. I don't know. Cryptographic stuff. Though I am somewhat familiar with it. I don't know this exact, like... I'm not entirely specifically sure with this particular use case. Like, obviously, or maybe not obviously, EDCSA, which should be ECDSA, so spelling, typo, is an algorithm for like cryptographic signing using elliptic curves. P256 is a class of curves that you can encrypt with or perform signature operations with, because there's not really enough key space to encrypt with elliptic curves, but you can still do key verifications with them. Whereas, or key derivations, I should say. And AES GCM, this is some modification of the AES algorithm over a Galois space to, I forget if it was to like do signatures or to do like signatures while encrypting, something like this. I don't remember exactly. So are we suggesting that it's like over consuming or over producing input or outputs? Oh, yeah. So in my list here, in this here call, this is kind of like sort of a thing. Sort of a thing. Recursive calls. I feel like I could take recursive calls by keeping track of some sort of array of items. And if the grammar item that we are currently processing is in a contextual array, then we could use that instead of the set to maybe calculate recursion or whatever. Yeah, recursion. Let's do recursion with arrays. Recursion with array. This hopefully will not break things. Maybe. Hi. So I could say the visit stack is just an array of grammar item. And instead of this, we could say visit stack includes grammar. And then we could push the current grammar. And over here, visit stack can pop the current grammar. Very important. Okay, and my program does not explode. So it still does what we need it to do. But if we encounter an item, maybe I want my descend function to return some sort of maybe status on like the number of something to do with like I guess whether or not it consumes the token successfully. Like that's kind of a hard thing to like I guess properly describe. might just change this to work a little bit differently, kind of like how it did, but print out first and then descend. It's probably a good idea, and then we don't need to check alt items at all in here because we already did that. So let's say the first item here is, I don't know, this line break, for example. And the line break has the option of either processing end of line or just empty. So it consumes basically like no tokens. In theory, the descend grammar function could return the number of tokens that it effectively consumes. So we could make this return numbers. And obviously if we consume nothing, we want to return -1. And then we'll have to keep track of tokens. Tokens eaten. Which could also just inherently be no tokens. So we'll get yum equal descend to grammar, and then if the token's eaten, well, if yum is greater than -1, then we want the tokens eaten be set to a number. Like if it's -1 right now, then we want to make it yum. Otherwise, it will be, we'll add yum. We will make it add yum. Another way of writing this is the expression style. Just be like, you have this, and then otherwise it's like yum plus the tokens. And hopefully I don't remember what the precedence on that was. Staircase. My code is a staircase of conditions. Yuck. For if There is an easy way to not if do. See, like, I wrote this, like, in a forward pattern, kind of expecting there to be, like, something here. Like an else condition. But there isn't an else condition. So what you can do is, like, you could be like, if it's not an object, or if name is like not inside the thing, and then we can leave, and then like, if this I here is, I don't know, greater than 0, you can leave. This last one is a bit of an expression that I don't know if I could actually, like, condense or not. Let else return. The else return pattern. Lots of languages have this sort of pattern. I don't want my program just to, like, leave. I think that's asking it a bit much, though. Anyways, we want to step into the grammar. And then we have an expected item. And the expected item can either be a token or a grammar item. And basically what I want here is to allow it to I guess figure out how many items that we have matched. And if they do match, I think we want it to, like, trigger the alternate. Which is sort of like, I'm not actually sure. Not actually sure how to make that work. Like the new line list, for example, can contain an end of the line, or it can contain a new line list, which is again another end of the line. The indentation. The indentation. If you have a bunch of, like, if let in Rust, you might want to consider functional programming. Just do a bunch of, like, map and dot and then dot and then dot and then dot map dot and then, that sort of thing. Like, I know you can't always get away with this, but, like, you usually can. It is in fact possible. almost wonder if I should try to make this like the longest series of tokens or something. Like, what if we made it so that, like, the number of, maybe, like, how about we have, like, the number of items in the alternate, and then we calculate the number of items in the alternate that match, and then if there's not enough of them, then we, I don't know, discard that alternate or something. So we have the match count, so we're going to set this to 0. And then maybe we don't actually want to, like, I don't know, maybe we don't want the actual number of tokens per se. Maybe we want whether or not it matches, which is sort of like what this value is. I guess if this value is greater than -1, then we can assume that the grammar matches, and thus we can increment the match count. And then if our current index is not equal to the current match count, I think we actually want to, like, leave the list. And then if we have the match count equal to the alternate's length, then we could say that the alternate matches. Maybe? And then if that happens, then we could say I don't know, let's say if the tokens eaten could be a thing. I'd probably have to do this, like, per alternate, though. And then, like, pick the alternate. that does match, because that's sort of like a bit of an eek. Okay, so maybe my program will a little bit further, or maybe it won't. Or maybe it will go all the way down. I don't know. Very eek. All right, so what does this do here? We have an alternate. We have an alternate. I guess we could like print out. Like alt match, and then in here we could say item match, the expected item then. Because there is kind of sort of a lot of stuff in here. Definitely, kind of, sort of, probably. We can have program. We have a line break, a new line list. So we have a match for line break. So then it will process what? Complete commands. We have complete commands, which is like, I don't know, plural. Very plural. Command. Command could consist of a complete command. It can consist of a list. A list can consist of a list. Or a separator operator thingy. An and or can consist of a pipeline. Pipeline can consist of a pipe sequence, which can consist of a command, which can consist of a simple command, which can consist of a command prefix, which can consist of an IO redirect, which can consist of an IO file, which can consist of any one of these, and none of that. You can have an IO number, an IO location, an IO here, which has one of these symbols, but it doesn't. You have IO number, IO location. I have either of those. You have a command prefix. You have an assignment word. Very command, very prefix. Very IO redirect, very IO file that can have like any of those symbols. All the IO file symbols again. I think if we have tokens, if we have something that requires a token, I should probably keep track of, let's say, the alternate list tree thing. Also, hello and welcome to the Christopher 1955. I think almost every single time I'm going to read the name slightly differently. Ever so slightly different. Well, see now it's listing out IO file each time, IO number location here each time, IO number location, IO redirect, and prefix assignment word, and name, reserved word, command name, reserved word, command, compound command, brace group, sub shell, for clause. We'd have the for keyword. If we want to hit any of these, which we don't, you'd have the case clause. You'd have the if clause, the while clause, the reserve clause. We already did the for clause. Yeah. Yeah. So I want to figure out how to build, I guess, a list of options, a list of, I guess, potential forward tokens. And then maybe like what item might be expected? Possibly. Now we might also want to remove or do the visited set. Like that should reduce the number of items in here, right? Yeah, greatly so. Greatly so. So then we could have like, I don't know, expectations. Imagine Misaka having expectations. It could be flex token or string array. Mysterious expectations. Yes, because if we have alternates, Like if we have this thing being like non-object or like not a name, that means that the expected item is probably a lex token. Or maybe it's a string, I don't know. I think I would expect it to be a string if it gets here. Peculiar. So if it's something like that, we want to like check if the list of expectations has whatever we expected here. Or maybe it should be, if it doesn't, I'm going to add whatever that is. Whatever that is. And then after we do that, should be able to like print out expectations. It's a giant array of token objects. Yay. So we can have end of line, any one of these tokens here, an IO number token, IO location token, any one of these tokens, assignment word, reserved word. I don't know what would be considered reserved word. We have one of these, for, case, if, while, until, or any of these. Although I don't know how the hell I would end up with an or. That might be a failing on the part of the grammar. Or is it? Can you do that? Can you just have like an empty token? No, I didn't. I wouldn't think that you could just have like an empty token. Like there has to be something in here. I don't know how it would have like matched the and if, unless you could have an empty pipeline, and I don't think you can have an empty pipeline. I think you have to have pipeline, pipe sequence, command, simple command, or compound command, or function definition. Or simple commands. Command name. Command name is a word. So we need a word. Or a prefix. We need some sort of prefix. I don't think we matched a word though. I think if we encounter I don't know, one of these word tokens. I also don't think we can have strings in the grammar items anymore. Very token. Too much token. I'd probably want this. Maybe like break out from the alternate? Or no? No, we want to check whether or not. Whatever it is. I don't know what it is. What it is. I need some of that gas. Type sequence, simple command, compound command, brace group. This should be like brace token, subshell token, for token, case token, if token, while token, until token. A compound command should not be a token cluster that matches. So, where the hell did it get like the and the or tokens from? Very virus. Much cloud. Alternate? You have alternate and or list complete program. I think we need the match count to go first. Alright, that gets rid of all of those. That's better. Better. Better, air quotes. Don't know how much better, but like it's a bit of a step in the right direction, maybe. I don't have weird data types just laying around. So all of these should be like valid things. Kinda. Kinda. I'm not exactly about to claim that they are 100%, but close. But we could, in theory, be like... event not found. Could do that. A shell, a sub-shell that executes nothing. Yeah. Alright, so I've sort of kind of halfway figured out how to get it to like sort of detect what's like in the current list. A subshell that executes nothing is the title of the autobiography by Nymphius. That's got some potency to it. For real. For real. Very yeah. Where the hell am I in my playlist? I'm going to I might have to skip over a few items. I do that. Sometimes I do that. Yeah. End of line. You have either an end of the line or you can have any one of these other symbols. Which means that I need a way for the parser, the grammar system, to inherently, like, I don't know, figure out whether or not any of these items in here in particular are allowed. Which means I need to keep track of, I guess, like, which grammar items, which paths we are taken. If we've taken a path, then the path should, like, this should, like, turn into something, some sort of, like, token that might appear in the stream of current items, the current tokens. I'm just not speaking very well because I don't really know what we have to do yet, but I'm pretty sure that we need to take grammar items. I'm going to put them in some sort of stack. Some kind of stack or list. Maybe like a list of, I don't know, grammar candidates. Let's say. Because I also need the program to sort of tell me what it's doing enough to make sense of what it's doing. It's a pretty good start, though. Like, it's able to turn the grammatical hierarchy into just like some big giant list of tokens that are expected, which is kind of, I don't know, I dare say that's sort of vaguely impressive. I don't know why. I don't know why that shouldn't be impressive, but it is. It's not even all that complicated. Yet. Not complicated. Yet. It lacks complication. Yet. Because for each of, let's say, the expected items, there will probably, by virtue of just the way this works, be some sort of current series of stack items, the path, thus we could take the current path the current stack path. Now we could save a copy of that along with like whatever token is expected. And that could be like I don't know, the current item. Maybe. Possibly. Which means that expectations here need to be an object. You need to be an object that like locates some sort of token. An array of objects that consists of a token and a path. It's going to be a grammar item array. I love that you can use like either commas or semicolons in here. It doesn't care. Wish other languages were like that. Certain other languages need to be more like that. That would be helpful. Probably. Alright, so what do we got? We got the expected item. We have our path, which is going to be a splat of the current visit stack. And then if we go down here, it'd be like E of the expectations. And then we could have E token. None of token. The Duncan? The Duncan token? Token Duncan? Token Duncan Diamond? Ayaya? Go back to program. Lovely. By lovely, I mean not lovely. I can't read that. It is nonsense. Also a very deep path. It's a deep rammer traversal path. We need a function. It can be make grammar. And then we can have the name. And then you can return grammar item. Except it's not going to actually return grammar item. I'm gonna use an object create. Maybe. So you choose string. And we want the item name. So then we have item, we give it a name, and then we return the item. And be like, okay. I don't know why I didn't just, I don't know. Why didn't I just make these a little bit more, I don't know, sensible, maybe? But I'm not known for being sensible. Third equals thing name. The stringy thingy. The stringy thingy. Not the stringy thingy. Make grammar. See, it could just be like anything, really. Is that constant word? You don't want to delete the constant word. I really don't want to delete the constant word. That was like so not worth doing it like that. All right, now you can be thing. You can be list of strings. Program, complete commands, complete command list and or pipeline, pipe sequence command, simple command, command prefix, IO redirect. Or it could be an end of line. Mm-hmm. Although I don't know if I want to actually like include program or not in the grammar. Seems like a little bit unusual. Like most of these are IO file, your IO redirect, your IO here, you're just a command prefix. You are a command name, which is just any word. Just a word, any word, but not that word. I definitely cannot have that word. And we have brace groups, subshells, for clauses, case clauses, if clauses, while, until. Many options. For what could be. So if I had, for example, an empty program, it should probably immediately match end of line, and then maybe come to a close. It's very hard to say. It's kind of very difficult to say. Also, I might want to like I don't know if I want to put program in the traversal list or not. I mean, I probably do. But it seems weird. A maze? A winding maze? Also, hello and welcome to the Yiffweed. I'm in a maze of twisty parsing directions. All very much alike. It's add day. Add day. Add day. Add demas. Add demas. We got word list. List of words. Words that are listed. Words that are somehow listed. Words that are somehow listed. Somewhat. Very slightly. Well, now I have to wait for it. The infamous. The obnoxious. The and break. Very. Brain go blap. Sometimes. A brain will plop sometimes. Right, yeah. So, now that ad break has gone, we have lists of words, and a great many of them. We also have lists of, potential grammatical paths, you might say. Like pretty much everything in here is all related to what can exist. I guess this is what kind of makes grammars a little bit weird. They're kind of like these weird recursive programs that sort of kind of tell you everything that could possibly exist. And that's sort of like, I don't know, a fun little microcosm of a fact. The grammars. The grammars. The grammars. Because the grammars are recursive. I think this would sort of naturally lend itself to like recursive descent parsing. It's just grandmas all the way down. Although I wouldn't really think of it like that. Grammar. The grammar. The grammar. The temptation to say is just babushkas all the way down. Or obachan all the way down. just to like twist the language even further. Because depending on what symbol we have here, like let's say you were to type an exclamation point. At that point, you could have a program, complete commands, which consists of a complete command, which consists of a list, and then a pipeline. And not much else. Whereas like any other token in existence is the start of a pipe sequence. Why are we talking about eggs? Oh yeah. Always with the eggs. Can I like move this over? But yeah, you pick up some of the most random nonsense, I swear. Absolute random nonsense. I don't think we've ever agreed to this. I don't think we've ever agreed to any of this. And yeah. What are you? You are Rule 4. Do not apply Rule 4. There's all these edge cases. There's a whole bunch of like rule edge cases. Like we have to do Rule 5. When the token meets requirements for a name, token identifier before a name shall result. Otherwise, the token word shall be returned. And I'm like, very, I wonder if I could bake that into the grammar in some way. Maybe the grammar will bake that into you. So much A? I have been coronated. The grand coronation of the Mesaka. It's been disintegrate. What happens at the end of the year? Do I expire? Do I become a new Mesaka? Do I get given a different persona? Does the sealing ritual happen? So many unanswered questions. The word of assignment is very assigned. Alright, so I should stop, like, I don't know, staring at it and maybe come up with, like, some sort of, like, way to, I guess, designate one of these options as actually taking place. Because, let's see here, we have, for example, the current tokens. And we could look at the current tokens, probably. Maybe we have, like, tokens read or something. Just disappearing again. Very E. Just in and out, in and out. Far and away. So I'm going to just send grammar and let's give it like a number. Another number, which is the token index. The ever important token index. And let's put that in my giant array of expectation. What is this? Cryptophilology? Crypto falafel? Do I want the tokens eaten? Or do I want token index? Cryptophrenology. Tokens are not food? Are they though? Have you ever eaten tokens? Have you ever eaten any tokens? They might be delicious for all you know. Let me shout out. Bad cop. Also, hello, hello. Welcome, welcome. Premium quality. Stream shout out right there. Premium. highest quality. I feel like I need the number of tokens. But maybe I don't. Maybe I just need like whether or not the grammar item matches successfully or something. I don't know though. I don't know though. I'm not entirely sure. Well, it didn't explode. That's always a good sign. But it didn't really do anything to it. So now that we have this way of like kind of sort of representing the token index, maybe we also get like the tokens eaten. That might be kind of sort of useful. Kind of sort of useful compliance. Also, what I'm thinking is maybe the grammar items get stored on some sort of list such that we have like a currently parsed series of tokens. And then we store the grammar items as what's it called? I don't know. Partial states of the program. I'm just making up technobabble at some points, I feel like. And it's probably not out of the it's probably not too far off. I think we want to take the tokens eaten value, set that to 0, and then do, I don't know, alternate match. Or some such. Be like yum. Somewhat yum. I could be like first come, first serve kind of style. And be like, if we match the item, and set this, leave loop, turn, is alt match, I don't know, 0 or -1. But like not really. We'll have, I guess, tokens eaten can be 0 always. So if we have a match, return the number of tokens eaten. Num 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 num. Num 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 yum. And then we can have token index plus the tokens that have been eaten. And that will give us a new token index. Probably. But what I should probably do is check to see if we have the token in question right here at this point in the program. That would probably be a good idea. Also, if I'm going to add these together, a variable. Put them in a variable. Then we should be able to be like current token, and then grab our context tokens, which is an array, and then have the current index, and we grab the token out of the current token list, which is going to be the token type or something. How you token type. You can be a string, or you can be whatever that is, or you can be a Lex token. Kind of a variety of things. A wide variety of things. That does sort of complicate the, like, I/O semantics here. Because you don't have, like, a perfect one-to-one correspondence of what tokens are actually what. Because when it comes to the tokens and the words and their values, some of them, when input, have to be like expanded and then like unquoted or whatever. Whereas when you have like shell language here, the quoted tokens don't count as like words, for instance. Count as quoted words, which are to be treated like, I don't know, regular word tokens, which is probably something that like I could handle by like inserting another step, and it would probably be fine. It's totally fine, but maybe it's not. I don't know. Maybe perhaps it is not, but maybe it is. Yeah, you never know. You never know sometimes. So that's a little bit what, I don't know, I guess shell expand is supposed to sort of take care of, sort of do, is to like maybe look at the current tokens in context. Because lexicographically, we're going to have like words, which are going to be strings, and the words that are strings have to be turned into like not strings, which is a sentence that doesn't really make any sense at all. Or like the quoted words have to be turned into like words instead of reserved word tokens or whatever. And then you have like the other lexicographic elements like the pipes or the list and or things. White space. That's the other thing. We have white space tokens just littered all over the place. For the most part, the shell will ignore white space tokens. It'll treat them as insignificant. Like they're only used to like disambiguate certain like combinations. So in a lot of ways, I don't necessarily need white space. In so many ways, we could just have like a lower level. Just shovel the white space into the abyss, never to be seen again. Unfortunately, that would not work. Unfortunately, I think we would need different tokens. I think we might actually need to keep the expand function. The shell expand function. This is probably something that needs to happen somewhat separately from the rest of the words. Maybe we do this as like push. Every time we call parse word, for example, maybe we like restore the current state of the grammar processing thing, and then we like compare the current word against like the current grammar states. We should hopefully get like pruned or like restored based on different criteria. Unfortunately, I didn't design this to be like reentrant and restored and like sort of kind of word iterative. I think iterative. Instead, it's a mess of recursive function calls. And there's not necessarily anything wrong with having a bunch of recursive function calls. But it does kind of lead to a bunch of different like parser states that are kind of somewhat not really what we want to have happen. So I think in order to make the whole thing like reentrant in some way, I have to turn it into a series of what's it called? iterative calls. I can't say that I'm making any more or less sense, but I feel like I'm making less sense. So, in order to make these iterative, we have to keep track of, I guess, basically all of the current variables that are in scope. So each iteration here is going to have the grammar array, the stack of grammar items. And basically the grammar stack has to be designed in such a way that you don't like revisit the same item unless it's been fulfilled or whatever. So yeah, that's sort of vaguely interesting. Interesting conundrum. And then, like, the visited items, this is sort of to prevent, like, there's tons of repetition. Tons of item repetition. But, like, if I am parsing stuff, we don't necessarily... I don't know, do we need this one? I kind of went back and forth on it earlier. And I'm like, I don't think we do. I think... yeah, it still gives me the same sort of output. So just checking the current stack should be sufficient. Should be. Also, we should probably just assume that the A value always exists. I accept full responsibility for things that don't include that. So let's see. Let's get rid of the visited set. And I think the call stack traces here also don't really help for readability at all, whatsoever. Go figure. Because, like, what I kind of wanted, ultimately, was just this whole, like, path and expectations kind of list. Is kind of what I was trying to do above, except more verbose, I guess. It should be like, I guess, which items aren't supported. I don't know. I could almost like put like grammar items. into the expectations list. In addition to lexicographics. Because that wouldn't cause me any grief. Really, really. 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 I'm not lying. Alright, next we need, I guess, the current grammar. Current grammar items. When we visit the stack of grammar items, I guess we would want to like skip whatever the alternate is instead of returning. So we have the expected item here. Instead of trying to descend into it and making the send function to it, we'll do it up here and be like, you're not what we're looking for, and then we just early break out of the thing. My thoughts on tariffs. What are my thoughts on tariffs? Why could you possibly ever be asking me about tariffs? Oh yeah, because that's the big ticket news item recently. Tariffs are supposed to be like small percentages, and I do mean small percentages, on like import or exports to encourage like local industry to be competitive. Thus, they have an actual real-world economic purpose. However, as I sort of mentioned earlier, they are supposed to be small values. If you have a global economy and your global economy happens to include some particular country that's really good at making some product very inexpensively, even with the tariff applied, this should just, you should allow this to happen. And you should keep the tariff rates low enough that it doesn't, like, I don't know, blow everything up. But still, like, give you give your country, like, a certain amount of, like, I don't know, economic import advantage, maybe. Except, like, it won't. The economics behind tariffs are, like, super complicated. If you delete all of the tariffs, then, like, obviously you're gonna have market dependent values on, like, the cost of imports, because, like, importing stuff is not free. but like it's more viable in some cases. So it kind of depends on like what kind of goods or services are being imported. And whether or not it even makes sense to tariff them in the first place. Because if you have an item that you are importing that your country does not make and you put tariffs on it, then that just raises the price for all of your citizens effectively, because like the company the country you're importing from, the country making the thing, the businesses making the thing are mostly just probably importing it to sell it to people. Obviously, this is going to be sort of an involved process. It's either going to be like an intermediate good or an end product. Putting some sort of tariff on end products is probably more sensible than like putting tariffs on like intermediate products, but still that could go either way. Because you got to be careful with that, because the economics are such that like you could have, I don't know, some product that's processed in some way, and then let's say you have, for example, computer cases. Computer cases are made of metal. Usually aluminum or iron, like sheets of steel. So, let's say you had some sort of ridiculous world where you have tariffs on steel imports, but not computer cases, for instance. And you kind of have to be careful with something like that, because you could accidentally make it so that computer cases cost less to buy and turn into steel than just importing steel, for example. So if you were to like put a tariff on steel and computer cases cost less than the steel that they are made of, even after recycling, then people in your country are going to be like, oh, I could just take a bunch of computer cases, buy them new, recycle them into steel, and profit. You don't want that to happen. You also don't want your tariffs to be like so high, such as to make all of your citizens suffer. You kind of want people to be able to live. Otherwise, you run into lots of weird economical recession driving problems that would probably be better if you just get rid of all the tariffs. Very yeah. This is a very long-winded explanation for some nonsense. You cannot import from Japan. Probably not. Probably not. You just this is sort of an example of like an entire country being like priced out of like viably existing, and people are either going to just like not buy the products anymore, or they're going to smuggle them into the country. And you don't want the latter to happen. So, like, yeah, if you exceed the threshold of, like, viably, like, promoting industry, at that point you're just making everyone suffer for no good reason. And unless the money you're getting from the tariffs is being reinvested into industry, which I can guarantee you that it is absolutely not. Nobody gets anything. Everybody loses. Because people are going to stop buying stuff, which means stuff is going to stop being imported. Which means that your tariffs are just going to be like, you're just going to like tank your import economy. And then instead of like, actually getting money from tariffs, you ultimately end up having the opposite effect where you end up with less money coming in from imports. Because you decided to make it impossible to import things at a reasonable price. So, stuff isn't going to be. It's the only people who can afford things are like, I guess it would be like obnoxiously rich people could afford to pay the tariffs. In a way, I guess. But ultimately, your economy kind of just falls apart. So, in other words, you should probably, maybe, let economists deal with setting that kind of stuff and not try to mess with it. Or else. Very much or else. I need more water. My throat is being all like ick again. Also, we have the duck pond for occasions like this. Obviously, it's not going to take me like super long to get water, but I will be back in a few minutes. And they have acquired more water, essential to power the Mesaka's continued endeavors. We do in fact have the ducks, which I was kind of pressured into running, despite the fact that it eats like a third of the CPU or something like this. Okay, it's a little bit of an exaggeration, but like it's been using between like 22% to like upwards of 30% of a 24 core CPU. And I attribute a large portion of this to like some sort of proton shenanigans. Like, I have no idea why it behaves like that. But at the same time, like, I don't know if I've ever, like, experimented to see what proton is doing. Because, like, as far as I know, the application itself doesn't really doesn't actually demand all that much. Like, there should be, like, I think maybe 2 cores being used at most, which is not even close to what it's actually using. VSync, I have no idea. But even if VSync was enabled or something, I feel like that would be that would be something that would still be like limited to like 2 or 3 CPU cores, not like an absurdly not like a quarter of the CPU cores. Like, I don't recall the program even having that many threads by itself. So there's something with the emulation layer. It's just not adding up at all. Very yeah. Let's see here. I need to run through grammar items. We essentially want to take the current status of this loop. So the alternate index alternate index. I guess it would be like these two index values. These are kind of like things. The tokens eaten, that's sort of like a temporary-ish value, kind of, sort of. Alternate here, this is sort of... It is a good Joe engine game, so I don't feel like it could even use that much CPU by default. There's something very, very profoundly unusual about using all the CPU. Very, I feel like I could take this and put this in a function. You're going to return string, and then you are an array of lex token or grammar item. Yeah, and then we can do text on alternate. If for some reason we need to display that, which I don't know if I will, keep that or not. Get rid of that one. I guess maybe if we have a match here, we return the tokens eaten. A maybe. We'll get our crazy lists. We get our large Printout of alternates, which does include duplicates. Okay, I guess there were some duplicates that we didn't really consider. Did not really consider those. So we say grammar item and expectations. And take that out of here. Kind of adds a little bit to the list here. I guess if it's already in the list of expectations, we can break. Since we always want to do this, this should be a little more clear if I hit it the other way around. Like if it's in there, then break. Otherwise, add it. Add it to the list. Line break, new line list, end of line. The emptiest of tokens. The lotus cushion. Hello, hello. we have line break because empty. Because empty. The great European shift. Reminds me I need to drink more of my water. I don't know how that would remind me to drink more of my water, but it does. So now we can expect line break. Line break, new line list, end of line. Beep boop. Ah. Ah. Don't even. I can't even. Can't believe that you don't know what the sound is. Or maybe I can. I don't know though. That's kind of wild. Kind of wild and crazy to think about. The ghost in the shell. You know, or maybe you don't know. I sort of need to watch the animated movie. I've seen, like, the live action Ghost in the Shell movie before. But I don't know if I've ever seen the animated one. And if I have, I don't remember it. I don't know. Maybe I could do that. Maybe I'll do that tomorrow if I'm, like, bored. Because I get bored pretty often, I guess. Somewhat, What is path? Path. Grammar item. Very, Just stare at the code and say, some more. I'm sure that will make sense. Eventually. Although, honestly, I'm trying to find the stack. The visit stack. This thing. So the visit stack is like where in the array of, I guess, like alternates or whatever, we encountered the particular item. So I almost want the, what's it called? The item visit stack to also contain the current status of the I guess the alternate search stack. Because this forms like a hierarchy of, I guess, possible grammar items, and we want the grammar items to be searched again later to make this program like capable of, I don't know, tree pruning or whatever, which is sort of the tactic that we want here. I want to be able to keep track of the indexes on things, such as the alternate index, which means that has to go into some sort of stack, which means that I have to take the visit stack and I guess we want to put that somewhere such that it gets like collapsed or whatever. So with the current stack here, instead of like pushing the current item into the stack immediately, we're going to probably push the item into the stack before we descend. And we're going to pull the item out of the stack after we return. Maybe. So instead of pushing the current item, we're going to push the, like, expected grammar item or whatever it's called. Pretty sure. Because I think that if the expected item is based on the alternate here that we're currently selecting, and the alternate has like a certain index associated with it, then we can essentially say that instead of pushing the item itself, which comes from the grammar based on the index, we could just push these index values, which are essentially like a representation of where these things are. So instead of having a list of the items in the visit stack, we have a list of objects where we have the grammar I guess we'd have like an index, and then we'd have like an alternate, which is like the another index. And we're going to push those instead. Which makes it really a lot more difficult to locate the current item. Like way harder. Eek. So I might want the grammar item actually. Just to make it easier to like search. So I'm gonna replace includes with find. And then we want the G item. So what we want here is we want to push I. We want to push the alternate index. And then we want to push the expected grammar item. Or is I the alternate index? So I can have AI in my code, unironically. Or did I get these backwards? Like the alternate is the outside item. No, you're the alternate index. You're the inside. Yeah, I'm just thinking about it backwards. That's actually correct. So I is kind of like it's sort of like where in the stack things are being kept. Maybe we turn it into some sort of interface, which is like a visit item. And then our path is going to be a series of visit items instead. More food detected. The cat does appear to be eating it. It's anyone's guess as to whether the cat will explode or not. Cats explode, right? So that works, right? You are what? Unreachable. Unreachable nonsense. We don't have to worry about you. However, we have this path item thing here, which is kind of yikes. The OS? The OS? What I want to do here. Turn an array that contains results. I'm going to map all the items. The OS that I'm writing or the OS that I'm using? This is sort of the question. This distribution, this is, what's it called? Arch Linux. And my desktop is Sway. The Sway desktop. Which is a Wayland version of i3, basically. I'm gonna like take all these items and like turn them into strings. So we have alternate number, and then we'll have, I don't know, field index or whatever. Tokens, token index or some such. The KDE. My question here would be, do you use multiple monitors or not? And it could just be that I'm silly or something. But what I'm curious is, do you have the screens set up to be like independent? Or can you like, or are they like connected together? I guess. Because X11 is kind of weird about spanned displays. And like, I've never investigated whether or not KDE supports, what's it called? Moving stuff between them? Because on my X11 desktop, they're considered different screens. They're considered independent. And the, like, window manager that I have in X11 mode doesn't let me take the items from one display and put them on the other display. They're kind of stuck on the displays that they're started on. Technically, it's running a single instance of the window manager, but like, it treats the different X screens as different, like, fundamental areas or something. I don't know how to explain it without, like, opening the X11 configuration and being like, it does this, this, and that. But it's basically, the window manager, there's a single instance of it, and it treats both displays separately. Because they're they're classified as different, what are called X11 screen numbers or whatever. So you have the different screens. A Saka EXE creepy pasta. Yikes. Gasp. Extra gasp. Also, hello and welcome to the Interrupt 45 hexadecimal. Very eek. So many eek. So many gift sub eek. Gasp eek. Gasp eek. Yikes. Instead of being freaked out, I should probably say like thank you or something. Or something. Or something. Probably. Probably. You break the Mesaka. Zero. It's a good show. I like that show. I need to watch that again. Because I think the last time I watched it, I only watched the first season, and I could swear they're probably out by with another one by now. Because it's been a while. Been kind of a long while. Yeah. It's been a little while if they have 3 seasons now. I only watched episodes of season 1. Because that's all there was. More content. I have so much content that I could just be like watching. I could just be watching and watching and watching and watching, and eventually I'm not going to have time to stream if I just watch stuff all the time. Or I'm not going to have time to do anything if I just watch stuff all the time. I watch stuff all the time. Case clones. I don't know if this alternate number is like thing that I want. What do we have here? We have expected. Which is an alternate item. So technically I want to format this so that the alternate item is the first number in the list Let me put the object last way in the list. The One Piece. There's way so many episodes of the One Piece. Will Luffy ever find the Piece of Eight? Oh, why'd that cut off? That alert box thingy is so jank, I swear. That's all. Not even. Nice, so many gift subs. Much thank you, thank you. Bye. Bye. I don't think my putting numbers in here makes this any more readable. It's the Kitco. 36. Hello and welcome. And the Hidoto. Don't remember if you were here earlier or not, but hello and welcome. If anything, I feel like this makes it less readable. Yeah. There's like so many shows that I want to watch. I feel like I'm never gonna get through them or something. Maybe that's just, I don't know. Random level of expectation speaking. You know what I want to do? I want to split this list. If it wraps around. Let's see, we can do 4. And then we can have, you know, V of E path. Very E, very path. And then E in the back and the right. I might be right back pretty soon. Like in like 5 minutes, I need to take, I need to get a break. Run a quick errand. In the middle of the stream. Because that's how we go, apparently. I can't overlap stretch break with it, otherwise I'm not going to be back for like ridiculous number of minutes. Too many ridiculous number of minutes. Yikes. That's sort of yikes. Well, I mean, maybe it's not too yikes. I do have the Duck Brigade going here on the other screen. You G path, E path. The walking. We're not walking. There will be no walking. There will be no walking on my watch. Okay, so if length exceeds 70, Such a weird way of doing this. The Code Trainer. I feel like I've heard this name before. In some way. Somewhere. Somehow. Break. What the break time? Why you break time? Why am I being... Why am I being... insisted? I'm trying to take my breaks early. Yeah. So much yeah. Anyways, I have big giant list of items here. What do I need? I'm gonna take the string. Put that there. So it doesn't actually go over the end of the line. I mean, I could make it 80 or something. That's probably fine. That's probably fine. Maybe. Although I might want like some sort of list or something. Some better form of list or something. There's my little notification thingy. Yeah. Yeah. Should have probably, instead of being like typing or whatever, maybe I should have been setting the sound level or whatever. We have the pond. There are ducks in the pond. Just kind of like chilling. Just kind of chilling. I haven't really poked this much. But yeah, I started this up earlier. Again, under duress, being pressured. knowing that I would take a break. So, yeah. It's gonna be the extra break time. And then I'm gonna disappear. We're gonna disappear. So I don't know why you would gamma prism me. I'm gonna disappear. It's counterintuitive.